Welcome to lesson 65, identifying quadratic functions. It is our first lesson in this new unit. So here's our CFS. We're going to correctly identify quadratic functions either by a graph, and that means looking for parabolas because quadratic functions will create parabolas, and correctly identifying quadratic functions from an equation, and we're going to have a look for that. We're going to try and find the highest degree of 2. All right, so let's look at the notes section, just high level work. We've looked at 3 different types of equations and functions: linear, quadratic, and exponential. And we know, and I'm going to start with this set over here, if we were to go into our graphing calculator and graph any of these examples, we're going to have a straight line. So it's going to be linear. This is how we can recognize it. It's just going to look like a line. The equations themselves can be written in 2 different forms that we're very used to at this point. They can be written in our slope-intercept form, or they can be written in our standard form. And that's when we simplify them, we can express them in either one. And the one thing we can look for is that the variable has an exponent of 1, meaning it is to the first degree. And so when I look at these, notice there is no exponent next to the x because they're all to the first degree. There's no exponent written. They're all to the first power. All right, so now we know how to recognize them on the graph. They look like lines. And looking at the equation, we know the form, and we know that there is no second power, third power, anything like that. Let's look at exponential. And just looking at the exponential equations, what do you see and what do you notice that's different from here? Well, one, you notice that the x is the exponent. That's the first thing that's pretty interesting that you'll notice. So when you see that, when the x is the exponent, it is exponential. And when you try to graph an exponential function, it's going to create a curve, either a curve up, whoop, or a curve down, whoop, something like that. But it's definitely not a straight line. It's just curved, meaning it's going to start slow and then it's going to quickly get bigger or quickly get lower. In terms of the equation itself, they're going to look like this one down here. Y equals AB, and x is the exponent to the x power. And usually it's plus or minus some type of number. Now, sometimes like this one here, there's no k, so it would just be plus 0. There's nothing there. And sometimes there is a number there, like this one here, where there's a 2. All right, so that's how we can recognize our exponential functions, because they have an exponent of x. We spent a lot of time in the last unit talking about quadratics, so let's go in there. Let's start really exploring these now and looking at these quadratic functions. You can see they're written in that form. What do you see? What do you notice? Well, I notice that they're definitely not exponential, but notice that the highest degree is 2. They're to the second degree. So when you try graphing these, they're going to make that u, and this is a parabola. Had a little trouble saying that. Parabolas can go up, they can go down, they can go sideways. So they look like u's, and they can go in any of those directions. And we're going to learn a lot more about which direction and why and how to recognize and how to predict it. They are written in this format when simplified: ax squared plus bx plus c. That's the standard for quadratic functions. And again, recognizing that they are to the second degree, meaning x to the second power is the highest degree. Okay, so using this now, you kind of know, if I were to give you a graph, you can say, oh, that's exponential, oh, that's quadratic, because we know what to look for: either a parabola, that curved line that either gets going up or going down, or a line. That's going to tell you what kind of function you have, as well as when you look at the equation. I'm pretty sure with the graphs you'll be able to see them and get that pretty quickly, but I want to just play with the equations a little bit more. So let's look at these 2 here. And let's start with the first one. The first one, let's rewrite it so that it is in a standard y equals type form. So I'm going to move the x squared. So y plus 3x is equal to x squared plus 6. And let's move this one also. And now it's written in a standard form. We can clearly see it's a quadratic. And even before I did that, you could have recognized it by seeing the highest degree was 2. Okay, so we know that this is going to make, when graphed, is going to make a parabola. We'll learn more about what direction, if it's going up, down, left, or right. We'll learn more about that later, but this is what we know so far. Let's look at the second one, and it's already written in a standard slope form, so we can tell that this is linear. It's to the first degree. We can see the slope is going to be 2. The slope is 2. We could already see the y-intercept is going to be 0.5, and that this is going to create, when graphed, a line. And we know a lot about the line already just from this information. All right, so hit pause and jot this into your notes. And take a look at this last one, an f of x. Try for yourself, determine, is it linear, exponential, or a quadratic? What do you see? What do you notice? Make a prediction. Tell me everything you know based on what you see. Okay, so looking at this one, this is absolutely quadratic. We're not even worried that it says f of x. That's fine. I'm going to rewrite this from this form to a standard descending form. Over here, we can absolutely already recognize, even before that, that it is to the second degree. So we know it is definitely going to make a parabola. And at this point, that's all we know about this, just from this information. All right, and that's it. So what you also could have done is just taken this and put this in your graphing calculator and looked at the shape. That's just another way if you can't recognize it from the equation. But using that is how you can use and practice your CFS, being able to correctly identify just by looking at the graph and just seeing it from the equation. You should be able to spot those quadratics, spot those exponential, and definitely at this point, spot those linear equations. Well, that's it for today's lesson. I'll see you in the next one, Math Marbles. Be well.